NM cable is not inherently fire resistant and must be protected from physical damage according to National Electrical Code Article 334.15. In the situation described, the NM cable rising through the wood structure is exposed to potential damage from fire or impact. SE cable also requires protection from physical damage, as per NEC Article 338.10. The lack of protection for the SE cable feeders from the meter enclosures to the tenant load centers is a violation of this code. The caulk gun fireproofing at the floors is not considered adequate protection for the cables according to the NEC. Article 80.21 requires cables to be enclosed in a fire-resistant assembly or installed in a listed cable tray system designed to limit the spread of electrical failure. Article 80.21 applies to cables installed in vertical shafts or ducts. It requires that the cables be enclosed in a fire-resistant assembly or installed in a cable tray system. However, in this case, the cables are not installed in a vertical shaft or duct. Article 80.1315 applies to cables installed in concealed spaces behind finished surfaces. It allows NM cable to be installed in concealed spaces, provided that it is protected from physical damage by a non-combustible raceway or similar protection. However, in this case, the NM cable is not installed in a concealed space behind a finished surface. Firstly, the responsible electrical contractor should be required to correct the violations by installing proper protection for the NM and SE cables. Secondly, the electrical inspector should be notified of the violations and asked to re-inspect the installation. Thirdly, the local authority having jurisdiction or should be made aware of the issue to ensure that future inspections enforce the applicable code requirements. It is important to address these concerns promptly to ensure the safety of the building occupants and the integrity of the electrical system. NEC Article 334.15 covers protection from physical damage for non-metallic sheath cable, type NM. In exposed work, NM cable must follow the surface of the building finish or running boards. It should be protected where subject to physical damage. When installed through floor joists, rafters, or studs, the cable should be protected by a substantial guard strip at least 1 inch thick and as high as the cable. Free air cable installed using the cable tray fill from NEC 392.22 could be damaged unless protected from the environment. NEC Article 338.10 dictates that service entrance cables must be protected against physical damage. If installed in a location where subject to physical damage, the cables must be protected by one or more of the following methods. Firstly, by rigid metal conduit. Secondly, by intermediate metal conduit. Thirdly, by rigid polyvinyl chloride conduit. Fourthly, by electrical metallic tubing. Fifthly, by electrical non-metallic tubing. Sixthly, by cable armor. Fire stopping is addressed in NEC 300.21, which focuses on the spread of fire and products of combustion. Electrical installations must be made in such a way that the fire resistance and integrity of fire-rated walls, ceilings, and floors is maintained. Openings around electrical penetrations must be sealed or closed with approved methods to prevent the spread of fire. Using caulking alone may not meet the requirements for maintaining the fire resistance rating of the building structure. Fire-rated sealants, listed for the specific application, must be used in fire-rated assemblies. NEC Article 80.21 applies to cables installed in vertical shafts or ducts. It requires that the cables be enclosed in a fire-resistant assembly or installed in a cable tray system. However, in this case, the cables are not installed in a vertical shaft or duct. Article 80.1315 applies to cables installed in concealed spaces behind finished surfaces. It allows an NM cable to be installed in concealed spaces, provided that it is protected from physical damage by a non-combustible raceway or similar protection. However, in this case, the NM cable is not installed in a concealed space behind a finished surface. The reference to the inspector passing the rough-in inspection despite the code violations is concerning. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations are safe and compliant. If an inspector is aware of code violations and does not take action to correct them, it could create a dangerous situation. It is important to address these concerns promptly to ensure the safety of the building occupants and the integrity of the electrical system. NM cable, or non-metallic sheath cable, is commonly used for residential wiring because it is relatively inexpensive and easy to install. However, it is important to follow all applicable code requirements when installing NM cable to ensure safety. One of the most important requirements is to protect NM cable from physical damage. This is because NM cable is not very durable and can be easily damaged by impact, abrasion, or other physical forces. If NM cable is damaged, it can create a fire hazard or electrical shock hazard. There are several ways to protect NM cable from physical damage. One way is to install it in a conduit. Conduit is a metal or plastic pipe that protects the cable from physical damage. Another way to protect NM cable is to run it through a protected area, such as a wall cavity or ceiling. If you are running NM cable through a wall cavity or ceiling, be sure to use a cable staple to secure the cable to the framing. This will prevent the cable from moving around and becoming damaged. It is also important to avoid running NM cable in areas where it is likely to be exposed to moisture. Moisture can damage NM cable and create a fire hazard. If you must run NM cable in a damp area, be sure to use a moisture-resistant cable. Finally, it is important to inspect NM cable regularly for any signs of damage. If you see any damage, such as cracks, cuts, or abrasions, replace the cable immediately. Following these tips will help you protect NM cable from physical damage and ensure the safety of your electrical system. SE cable, or service entrance cable, is used to connect the utility company's service drop to the electrical panel in your home. It is important to protect SE cable from physical damage because it carries a large amount of electricity. If SE cable is damaged, it can create a fire hazard or electrical shock hazard. There are several ways to protect SE cable from physical damage. One way is to install it in a conduit. Conduit is a metal or plastic pipe that protects the cable from physical damage. Another way to protect SE cable is to run it underground. If you are running SE cable underground, be sure to bury it deep enough to protect it from being damaged by digging or other activities. It is also important to avoid running SE cable in areas where it is likely to be exposed to moisture. Moisture can damage SE cable and create a fire hazard. If you must run SE cable in a damp area, be sure to use a moisture-resistant cable. Finally, it is important to inspect SE cable regularly for any signs of damage. If you see any damage, such as cracks, cuts, or abrasions, replace the cable immediately. Following these tips will help you protect SE cable from physical damage and ensure the safety of your electrical system. Fire stopping is a critical aspect of building safety. It involves the use of materials and methods to seal openings and joints in walls, floors, and ceilings to prevent the spread of fire and smoke. Fire stopping is essential for maintaining the fire resistance rating of a building, which is the amount of time a building or a component of a building can withstand a fire. The NEC requires fire stopping in several areas. For example, NEC 300.21 requires that electrical installations be made in such a way that the fire resistance integrity of fire-rated walls, ceilings, and floors is maintained. This means that any openings around electrical penetrations must be sealed or closed with approved methods to prevent the spread of fire. There are many different types of fire-stopping materials available. Some common materials include mineral wool, fiberglass, intumescent sealants, and fire-rated foams. The type of fire-stopping material that is used will depend on the specific application. When selecting a fire-stopping material, it is important to consider the following factors. Firstly, the fire resistance rating required. Secondly, the type of construction. Thirdly, the size and shape of the opening. Fourthly, the environmental conditions. It is also important to follow the manufacturer's instructions for installing the fire-stopping material. Proper installation is essential to ensure that the fire-stopping material will perform as intended. Fire stopping is an important part of building safety. By properly fire-stopping your building, you can help to protect the lives of the occupants and prevent the spread of fire. The local authority having jurisdiction, or OJ, is the governmental agency that is responsible for enforcing the NEC and other building codes. The AHJ can be a city, county, state, or federal agency. The AHJ has the authority to inspect electrical installations, issue permits, and require corrective action if code violations are found. The AHJ also has the authority to shut down an electrical installation if it is deemed to be unsafe. It is important to be familiar with the AHJ requirements in your area. You can usually find this information on the AHJ website or by contacting the AHJ directly. When working on an electrical project, it is important to obtain all necessary permits from the AHJ. You should also schedule an inspection with the AHJ after the project is complete. The inspector will verify that the electrical installation meets all applicable code requirements. If the inspector finds any code violations, you will be required to correct them. It is important to cooperate with the AHJ and to correct any code violations promptly. This will help to ensure the safety of the electrical installation and to protect the lives of the building occupants. The electrical inspector plays a crucial role in ensuring the safety of electrical installations. Inspectors are responsible for enforcing the NEC and other applicable codes. They review plans, inspect installations, and identify code violations. When an inspector finds a code violation, they will issue a notice of violation. The notice of violation will specify the code violation and the corrective action that is required. The person who is responsible for the electrical installation must correct the code violation within the time frame specified in the notice of violation. If the code violation is not corrected, the inspector may take further action such as issuing a stop work order or referring the matter to the AHJ for enforcement. It is important to cooperate with the electrical inspector and to correct any code violations promptly. This will help to ensure the safety of the electrical installation and to protect the lives of the building occupants. When preparing for an electrical inspection, it is important to gather all necessary documents such as permits, plans, and specifications. You should also make sure that the electrical installation is accessible and that the inspector has a clear path to all areas that need to be inspected. It is also helpful to have a copy of the NEC available for reference. During the inspection, the inspector will typically start by reviewing the plans and specifications. They will then inspect the electrical installation to verify that it meets all applicable code requirements. The inspector will pay close attention to the following areas: firstly, wiring methods; secondly, grounding and bonding; thirdly, overcurrent protection; fourthly, equipment installation. The inspector may also ask questions about the electrical installation. It is important to answer these questions honestly and to provide any additional information that the inspector requests. After the inspection is complete, the inspector will provide you with a written report. The report will summarize the findings of the inspection and will list any code violations that were found. If the inspector finds any code violations, you will need to correct them within the time frame specified in the report. The electrical contractor is responsible for the safe and compliant installation of electrical systems. They must have a thorough understanding of the NEC and other applicable codes. They must also be skilled in the installation, maintenance, and repair of electrical equipment. When hiring an electrical contractor, it is important to choose a contractor who is licensed and insured. You should also ask for references and check the contractor's record with the local licensing board. A good electrical contractor will be able to provide you with a detailed estimate of the cost of the project. They will also be able to answer any questions that you have about the electrical installation. During the project, the electrical contractor will be responsible for obtaining all necessary permits and for scheduling inspections with the AHJ. They will also be responsible for ensuring that the electrical installation meets all applicable code requirements. After the project is complete, the electrical contractor will provide you with a certificate of completion. This certificate verifies that the electrical installation has been inspected and that it meets all applicable code requirements. Choosing a qualified electrical contractor is essential for ensuring the safety and reliability of your electrical system.